Look up at the night sky. In the quiet hours of the night, when the world is still, the cosmos stares back at us with a billion unblinking eyes. For as long as humans have looked up, we have asked the same question: are we alone? It is the greatest paradox of our existence. On one hand, we live in a universe so incomprehensibly large that the number of stars in the observable sky is comparable to the number of grains of sand on all the beaches of Earth. On the other hand, we have heard nothing. No radio signals, no probes, no grand galactic welcome. This great silence is not just a scientific mystery. It is a mirror reflecting our own insignificance and our boundless curiosity. To understand why we haven't found them, we must first understand the stage they would need to stand on. Many think aliens might live on stars, but that is a fundamental misunderstanding. Stars are not habitats, they are engines. They are gargantuan, volatile spheres of plasma, powered by the violent process of nuclear fusion. Our own sun, the life giver, is a furnace with a surface temperature of 5,500 degrees Celsius. In such an environment, the complex chemistry required for life as we know it would be torn apart at the molecular level. No, the search for life cannot be a search for stars. It must be a search for the fragile, rocky world, the terrestrial planet. We are looking for Goldilocks worlds, planets that are not too hot, not too cold, but just right, where liquid water can pool, flow, and harbor the chemical soup from which life might spring. For centuries, we could only dream of other worlds. Then came the Kepler Space Telescope, launched in 2009. How do you find a tiny, cold rock orbiting a star hundreds of light years away? You cannot look at it directly. It is like trying to spot a mosquito flying in front of a stadium floodlight from miles away. So, scientists developed the transit method. We look at the star and we wait. When a planet crosses the face of its host star, it causes a flicker, a tiny, rhythmic dip in brightness. By measuring these flickers, we can calculate the planet's size, its orbital period, and its proximity to the habitable zone. Kepler unveiled a universe far more crowded than we ever imagined. It gave us Kepler-22b, a super-Earth that dances in its star's habitable zone. It led us to K2-18b, where we detected the unmistakable signature of water vapor in the atmosphere. These are not just scientific data points. They are potential islands in a vast, dark ocean. We have found over 2,500 planets in a tiny patch of sky. If you extrapolate that across the Milky Way, there could be 20 billion terrestrial planets. The stage is set. The actors are everywhere. So, where is the performance? Here is the uncomfortable truth. The universe is not just big, it is aggressively, impossibly vast. Our solar system is a tiny bubble in a quiet, lonely suburb of the Milky Way. Even if there were a civilization just 4 light years away, our nearest neighbor, that distance is almost insurmountable. With our current technology, it would take a spacecraft over 17,000 years to travel just 1 light year. To reach Kepler-22b, a mere 600 light years away, we would be looking at a journey of 10 million years. Furthermore, consider the location of Earth. We are not in the bustling, resource-rich center of the galaxy where civilizations might collide, trade, and flourish. We are on the fringes. Perhaps advanced civilizations are out there, but they are focused on the galactic core, busy with things we cannot yet conceive. Or perhaps, the vastness of the universe acts as a natural quarantine, keeping every civilization isolated on its own island of space-time, unable to bridge the void. We must also ask ourselves, are we looking for the right thing? We have been scanning the stars for radio waves for a few decades, a blink of an eye in cosmic history. We assume aliens will communicate like us, with radio bursts and light signals. But what if they have moved beyond that? What if they use technologies or communication methods that we don't yet have the physics to understand? We are like a tribe living in the woods, trying to hear a conversation happening on the internet. We are limited by our own stage of evolution. Whether we are truly alone or merely part of a vast, silent cosmic community, the search itself is the most important thing we have ever done. It has forced us to look at our own planet with new eyes. We see Earth as a rare, blue miracle, a precious vessel of life in a cold, indifferent vacuum. If we find life elsewhere, it proves that life is a cosmic imperative. If we never find it, it makes our existence even more precious, more vital to protect. We are a young species, barely out of the cradle, standing on the edge of the shore, gazing into a boundless ocean. We haven't found them yet, but we will keep listening. Because in the silence of the stars, we are learning who we are.